Welcome to this tutorial. In this video, I'll be demonstrating the Chebyshev theorem. All right, and to do that, this is a topic in quantitative methods, or rather business mathematics, as others could be, business statistics in other courses. So it's basically one and the same thing. So let's observe the Chebyshev theorem using an example. All right. The distribution of home sales with a mean of $300,000 and a standard deviation of $50,000. Full stop. First question: determine the price range in which at least 75% of the houses are sold. All right. So we want to determine the price range. What we have is basically the mean and the standard deviation. Before I can begin the computation, I want to give you the formula for calculating the minimum percentage, because we basically use it to determine the range. So there are two formulas that I'm going to basically give you, which is the one for the range and the one for determining the minimum percentage using Chebyshev's theorem. Okay? In Chebyshev's theorem, the minimum percentage is calculated by simply saying 1 minus 1 over k squared, where the k is basically the number of standard deviations. K is basically the number of standard deviation. So this only applies to Chebyshev theorem, number of standard deviations, not the standard deviations, the number of standard deviations. All right, so we have that, and then this is the formula for the minimum percentage, and then the next formula that we're going to observe is the formula for calculating the range. Range is basically given by mean plus or minus k, which is the number of standard deviations, multiplied by the standard deviation. So where mu is basically the mean, k we've already said is the number of standard deviation, and this one should be theta to represent standard deviation. All right. So solution 1, if we are determining the price range in which at least 75% of the houses sold, the range, the formula is this one. Okay? Range, the formula is mean plus or minus k, which is the number of standard deviations, and then theta, which is the standard deviation itself. Now when you look at here, we have the mean, which is $300,000, and we have the standard deviation, which is $50,000, like that. All right, and we want the range. We cannot calculate the range, we need the k. The k we do not have. I'll put a question mark there. We do not have the k, which is the number of standard deviations. Now, we're applying this formula, we can apply this formula to get the K. This one for minimum what? Percentage. Because the minimum percentage we already have, which is the 75, the at least 75%. That's the minimum percentage. And 1 is part of the formula. So what we are caring about is the K. And we know for sure to say minimum percentage, minimum percent is given by 1 K squared. Okay? Is given by 1 minus 1 over K squared. Like that. And we have the minimum percentage, which is 75%. 75% is basically 0.75. Alright? And then we have 1 here, we have 1 there, we have K squared there. So what do we do now to get that? We can bring the 1 this side, so it will be 0.75. This one becomes a minus, is equal to negative 1 K squared. And then we have 0.75 minus 1, this will give us negative 0.25, is equal to negative 1 K squared. And then we can cross multiply here. Let me extend that. I'm just getting the K which I'm going to apply to get my range here. So now we can cross multiply. This will be negative 0.25 K squared is equal to this, and that will be negative 1. This and that has given us that. Okay? And then we can divide both sides by negative 0.25. This and that goes, we remain with K squared is equal to negative 1 divided by negative 0.25. I have 4 here. And then we are trying to eliminate the square there. We are going to square root both sides. K squared, 4 squared. So this will remain as K, and that will be 2. So now our K is 2, meaning now we can apply this formula to get the range. Have you seen? We can apply the formula now to get the range. So range is equal to mean, which is $300,000 plus or minus K, which is the number of standard deviations, multiplied by 50,000. Multiplied by 50,000. So our range now will be $300,000 plus or minus 2 multiplied by 50,000 is 100. Right? So our range now will be between, the first one is minus $300,000 minus $200,000, minus $100,000, that will be 200. So the minimum price is 200,000. That's the minimum price. And the maximum price will add. The range has got both minimum and maximum price. So the maximum price is, instead of subtracting, because it's plus or minus, we're going to add there 300,000 plus 100,000 to have 400,000, something like that. All right. So now we have the range of the price. Range is basically between 200,000 and 400,000. That's a range. So sometimes the examiner can not ask you for the range, can ask you to say calculate the maximum price, or can ask you to say calculate the minimum price. Meaning the examiner is basically looking for a $200,000 for the minimum price, or if he asks you to calculate the maximum price, he's basically looking for a $400,000. Now look, you need to understand this. You see something peculiar here. When the examiner is asking you for the range, he will give you the percentage. Are we together? When the examiner is asking you for the percentage, look at question 2. When the examiner is asking you for a percentage, he is giving you the range. In both ways, the only thing which will be missing is the K. So if he gives you the percentage, he needs you to find the range, you use the formula for percentage to get your K. If he gives you the range and then he wants the percentage, for you to get the minimum percentage, you will use the range to get your K. Look at what is going to happen. Let me remove this first answer. Or basically I can remove this and put my solution 2 here. Alright, so now solution 2. Solution 2, as you can see, here we are. Determine the minimum percentage of the houses that you did sell for prices between 150 and 450. I've used different currencies here. I was using dollars here. I've used Zambian kwacha, which is our local currency. It's okay. I'm just using this to demonstrate. Alright, so now here we are. We have to calculate the minimum percentage. The formula for minimum percentage, remember, the formula for minimum percentage is 1 minus 1 over K squared. Alright? This is the formula for minimum percentage we discussed. That's the formula for minimum percentage. I've written the formula here. Alright? This is what we are calculating. Alright? We don't have the K. In both cases, we didn't have the K. Here, we use the formula for minimum percentage to get the K. Now here, we are going to use the formula for the range to get the K. And I need to choose whether I need to use minus or plus. It's up to me. Okay? The answer will still be the same. Let me use the formula for minimum. So now, remember, minimum price. This is under the formula for range. Minimum price is just the mean, and then minus instead of plus. K standard deviation, like that. Okay? So the minimum price is 150. If I use the plus here, I was going to say maximum price, and I was going to bring 450 here. And the answer will still come out to be the same. Okay, so the minimum price is 150. Okay? And the mean is 300. Alright? I'm looking for the K. Let me write it properly. I'm looking for the K, but I have the standard deviation. The standard deviation is 50,000. This should be multiplied by K there. I'm looking for the K, so I can solve for the K in this manner. Okay? So now what I'll do is I'll simply bring the 300 this side. So it will be 150,000 minus 300,000. And then I have negative 50,000 K. Alright? And then from there, 150 minus 300, that will be negative 150,000. Negative 150,000 is equal to negative 50,000 K. Negative 50,000 this side, negative 50,000 this side. Therefore, this and that will cancel, and then this 50,000 into 150 will be 3. Therefore, my K is equal to 3. Okay, I can extend to here, no worries. Now, you see, like I said, in both cases, what we were lacking was the K. We are asked to calculate the minimum percentage, it gives the range. You are asked to calculate the minimum percentage, you are asked to calculate the range, it gives you the percentage. Okay? So now that we have the K, we can find the minimum percentage. Which is 1 K squared. And then we have 1 here, 1. And then the K is 3 here. So 3 squared, that will be 1 over 9. Let's see what this becomes. 3 squared is 9. 1 minus 1. 1 minus, open brackets, 1 divided by 9. That's how I like doing it. This gives me 0.8889. So now we can simply say the minimum percentage is 88.89%. Perfect. That's how it should be. Alright? So this is how your question can be tailored in the examination. The examiner will be asking you to determine the range. He hasn't given you what he will give you is the minimum percentage. So you use the formula for minimum percentage to get your K so that you can determine the range, because you already have the mean, you already have the standard deviation. What you don't have is the K. Okay? Secondly, the examiner will ask you to calculate the minimum percentage. He will give you the range. What he will deny you is the percentage itself, which is asking you to calculate. So you can use the range to come up with the K, like I have used the range here. Alright, thank you very much. This is the end of this tutorial.